What is the significance of juxtaglomerular apparatus in the kidney function? So students, now let's learn the significance of JGA, juxtaglomerular apparatus in the kidney function. Now this apparatus is found in some of the nephrons whose renal corpuscle is in close proximity of the DCT. So at this junction between the arteries, efferent and efferent arterioles and DCT, there are certain cells called juxtaglomerular cells. They are nothing but the modified smooth muscles present on the efferent arterioles and modified epithelial cells on the distal convoluted tubule. These modified epithelial cells, they are bigger in size when compared to other cells and they are called macula densa. Now both of them, juxtaglomerular cells and macula, together form juxtaglomerular apparatus. Now these apparatus produces an enzyme called renin. They secrete an enzyme called renin which can sense the blood pressure and which can sense the amount of glomerular filtration rate. So normally it is 125 milliliter per minute. So whenever there is a variation in this rate and in the blood pressure, the JGA complex secretes renin and this regulates the blood flow and maintains the volume of the glomerular filtration rate, that is GFR. It maintains the volume of GFR. So let's learn how it maintains it. So renin is secreted by the JGA complex and it is released into the blood. Now in the blood there is another protein called angiotensinogen. So this is released by the liver. So liver produces and releases it into the blood. So when this reaches the kidney, the renin which is released into the blood vessels by the juxtaglomerular apparatus converts the inactive form of angiotensinogen into active form angiotensin 1. So here from the inactive angiotensinogen it is converted to angiotensin 1 by the renin. Now from here this protein is taken into the lungs. In the lungs there is another enzyme, angiotensin converting enzyme ACE. Now this enzyme converts angiotensin 1 to angiotensin 2. So angiotensin 2 is obtained. Now this is angiotensin 2 is a powerful vasoconstrictor. It binds to the efferent and efferent arteriole and it makes the blood vessels to constrict. As the blood vessel constricts, the lumen decreases. When the lumen decreases, the blood pressure increases. And if the blood pressure increases, the rate of filtration increases. And hence, the juxtaglomerular apparatus maintains, it senses the difference in the blood pressure and the volume of the filtration rate. To bring it back to normal, it activates renin angiotensin mechanism which gives rise to angiotensin 2. Angiotensin 2 is a vasoconstrictor. It increases the rate of blood pressure in the blood vessels of efferent arteriole by constricting it so that the filtration rate increases. And similarly, it will induce the adrenal cortex to produce aldosterone. Now the kidney has two regions, the outer cortex and the inner medulla. Now the cortex cells on receiving angiotensin 2 produces aldosterone. Now this aldosterone binds to the distal convoluted tubule and it increases the absorption of the sodium ions. So aldosterone binds to distal convoluted tubule. So it binds to this part and it induces the reabsorption of sodium ions. So when the sodium ions enter the blood vessels, to maintain the osmotic balance, the water from the distal convoluted tubule enters into the peritubular capillaries. So it helps in reabsorbing the water and this leads to increased volume of the glomerular filtration. And thirdly, so this mechanism is referred to as renin angiotensin mechanism. And in another way, this angiotensin 2 induces the pituitary gland to produce ADH hormone. ADH hormone binds to distal convoluted tubule and further increases the reabsorption of the water. And it also increases thirst in the individual so that more amount of water is intaken. So, these are the significance of juxtaglomerular apparatus in the kidney function. So, it maintains the blood pressure and the volume of the glomerular filtrate in the ultrafiltration process, and in turn it maintains the volume of the fluid within the body.